Okay, in this section, we want to see and learn how to break down composite numbers using a product of prime numbers. Every composite number can be broken down using prime numbers. That's called prime factorization. So example, let's just say 48. Now 48, we could break this down with 3 times 16. 3 is a prime number, but 16 isn't. We can break 16 down even further. We can break that down as 4 times 4. Oh, here we have the 3. But now the 4s can still be broken down. So this first 4 is going to be 2 times 2. And this second 4 is going to be 2 times 2. Now, in this case, we can no longer break anything down. So we have 1, 2, 3, 4 2s and 1 3. So we simply say that's 2 to the 4th power times 3. And that's our prime factorization. Okay, let's look at this next one. Okay, let's look at this next one, and then we have 40. Now let's start off with 8 times 5. So we know 40 could be broken down with 8 times 5. The 8 is not a prime number, it's still composite. So let's break this down with 4 times 2, and then we still have our times 5. This 4 can still be broken down, so that's 2 times 2. 2 times 5. So in this case, now we can't break it down anymore because our 2s are prime and our 5 is prime. So how do we express this? 2 to the 3rd power times 5. We're breaking this down as a product of primes. Okay, let's go on to this next one. Let's look at this 50. Right here, I'm going to move this 50 over a bit. Okay, let's just break down 50. Let's just say that's 25 times 2. Now, 25 is not a prime number. That can still be broken down further. So for 25, let's just say 5 times 5, then times 2. Now we have all prime numbers that can no longer be broken down. So in here, I'm just going to say 2, just because I start with my smaller number. And since we have 2 5s, it's going to be 2 times 5 squared. And in this case, I'm going to have 54. So the first factors that come to my mind would be 9 times 6. Now, the 9 can be broken down as 3 times 3. And the 6 can be broken down as 3 times 2. Once again, these are all prime numbers. So we have 1, 2, and 3 3s. So we just break this down as 2 times 3 to the 3rd power. So these are just the small things that we do. Oh, and this is another question, because I always get this question. I'm going to use this randomly. People say, well, what if I use a different set of terms? It would not matter, because just say for 40, instead of 8 times 5, we decided to use 10 times 4. All right, we could still break it down. The 10, that would be 2 times 5. And the 4, that would be 2 times 2. So if we've broken down, but in the end, the prime factorization is going to be the same, because we still have, if we look at this bottom row, we still have 2 to the third power times 5, okay? And the same way, I'm just going to use it right here. When we use 25 times 2, let's just use for 50, let's just use 5 times 10. Okay, the 5 can't be broken down, but the 10 can be broken down into 5 times 2. So once again, that's going to be 2 because we have this left, and that's going to be 2 times 5 squared. So that won't make a difference because the prime factorization is unique. Okay, so in the end, you're going to get 1. Now, the way that we get there is not unique, but the prime factorization, our final way that we write it out, is unique.